Hello, we're going to talk about definite integrals. We've been doing indefinite integrals before. Those are the type where you need a plus c. In this case, you won't have a plus c when you're working with a definite integral. A definite integral has an upper and a lower bound. Those are x values that you're constraining your integral between those two x values. In this case, we are integrating 2x minus 3 from x equals -2 to x equals +1. So that's where you put your bounds on the floof. And when you're done integrating, I've written this other new notation in pink. That's how you write it when you're done integrating, but you haven't used the bounds yet. So when you use the bounds, you put the upper bound in the x squared minus 3x, and you put the lower bound in the x squared minus 3x, and then you subtract to find the difference between those. So it's plug in the upper bound, subtract, plug in the lower bound. That's all there is to this, and it's not too difficult. So the problem here is staying organized and not making sure you use parentheses so that you're subtracting the total thing from using the lower bound instead of just part of it. Often one of these bounds is 0, and you can get complacent kind of in thinking that you don't need to do the subtraction because part of it's all 0, but that's not true. You have to always remember that there are two bounds, and sometimes you'll get 0 and sometimes you won't. Particularly this shows up if you have a problem with exponentials or logarithms in there where you think it might all wipe out, but it actually doesn't. So here we go. We're going to put the 1 in first and then do a big subtraction. So we're going to subtract what we get when we put the -2 in. And that turned out to be a -12 in this case, and you're done. All right. Thank you, and have a great day.